3 things flat earthers are not telling you in their laser videos, and the third is the most important. Number 1, laser beams fan out over long distances. It's called laser beam divergence. In other words, if you measure 1-inch diameter laser beam 1 foot from the laser, 1 mile down the road, it's not going to be 1-inch diameter, it's going to be significantly larger because it fans out. Data sheets produced by laser manufacturers document its beam divergence, and it can be quite significant. Look at these documents. Look at these numbers. Number 2, even though you can see light from the laser doesn't mean you are in the direct path of the laser beam. Lasers produce a spillover light. If you were looking directly into a laser beam, it would be blinding. And number 3, most importantly, a laser beam can actually bend under certain conditions. And I'm going to show you in just a minute. You see, light does not bend in a vacuum. Light does not bend when it is traveling through a material of consistent density. Keywords, consistent density. When light travels through a material of gradient density, it bends. Have you ever noticed a wavy, blurry effect over a fire or a hot surface? That happens because light bends. The heat from the fire makes the air above it hotter and thus less dense than the surrounding air. Thus, light bends, producing a wavy or blurry effect. Whenever light passes through a material of varying densities, it bends. Here's a video clip by Action Labs that clearly demonstrates this fact. This gentleman is shining a laser beam through a gradient index material. The liquid on the bottom of the cube is denser than the liquid on the top. It gradually gets denser as you reach the bottom of the cube. You can clearly see the laser beam bending as it goes through the gradient index material. This has been clearly demonstrated by many people. Here's how it works. When light is shining through a gradient index material, the light bends toward the denser material. The liquid on the bottom of this cube is denser. That is why the laser beam bends downward. The opposite happens when you see a mirage on the road. The warm road makes the air immediately above the road warmer and thus lighter, less dense. So the light coming from objects above the road, shining down towards the road, bends back upward toward the denser air. That's what makes it appear to be reflective. The opposite happens at a large body of water because the air is more dense near the water. The cube you saw earlier is like a mini version of the Earth's atmosphere. Remember, there is less oxygen at higher altitudes. That's why some people who climb Mount Everest die from lack of oxygen. That's why there has to be pressurized cabins in planes. The higher you go, the less air you have. As you descend, the air gets more dense, especially the air above a large body of water, as it would be more dense with humidity. The closer you get to the water, the more dense it becomes. It is a gradient index material, just like the material in the cube. For example, the air 5 feet above a large body of water is denser than the air 50 feet above the water, especially due to the humidity. So when you shine a laser beam over a large lake, it will bend downward following the curvature of the Earth. But here's the thing. Blue light has a higher refractive index as opposed to red light. You can see that on this graph. Why is it that flat Earth propagators use blue lasers? Just a coincidence? Or did they intentionally use a blue laser to deceive you? Because blue laser beams bend more than red. I challenge flat earthers to make a video where they use both blue and red lasers parallel to each other, proven at a midpoint over a large lake, because at a significant distance, such as 20 miles or more, you might be able to see the light from one laser or the other because of the beams that bend, but not both because blue and red light refract to different degrees over long distances in a gradient index material like the Earth's atmosphere. Bottom line, do not be deceived by these laser shows. Do not be bamboozled by bozos who are ignorant of optical physics. Laser light is not always straight. Flat earthers would say, well, it's ridiculous to say that a laser beam can bend. Because once again, flat earthers have a hard time understanding physics.